Hi, my name is Angelina. I am the research assistant for the Discovery STEM Educational Initiative here in the faculty. I work with Professor Kilkenny and the Discovery research team to both deliver and to study the Discovery educational program. So the key question that I was looking to address this summer was how to effectively design a longitudinal tracking framework to assess the long-term impact of discovery. And so what is Discovery? Discovery is an educational initiative aimed at delivering an inquiry-focused learning experiences for high school students. So we partner with TESB schools and educators to develop an inquiry-focused curriculum based on an engineering capstone format. And the idea there is to foster open-ended problem solving and critical thinking skills. And one of the educators that I interviewed during in the summer said this about the program. It's students are doing research and they're not provided with a method. They have to figure out the methods themselves for their research project. And that is different than the traditional knowledge-based curriculum in high school currently. So that's what makes Discovery a unique program. And so we deliver this program, but what we do, the Discovery team does also, is to study the program. So we have studied the program, studied the students in program, and we have positive results in improving student attitude towards STEM and also their grades, and so their academic performance. What we don't know and what the study aims to address is the long-term impact of Discovery and an inquiry-based learning method on students after they have exited the program. And so this is the premise of this study. And the present study focuses on designing a longitudinal tracking methodology to assess the long-term impact. And why that is important and why we put the time and effort for the design part is for longitudinal research. Once it has been implemented, it's hard to go back and change the methodologies upon implementation. So it's important to survey the literature to set the foundation and to minimize any design gaps and data gaps once the study has been implemented. So how do we do that? So we did this summer by doing a comprehensive literature review on STEM education, especially on longitudinal studies and also longitudinal research design research that then inform the result. So the result is presented in the table, the big table in the middle of the poster. So that's what the premise of the study will encompass. It will be an 8-year study with built-in exit points for post-discovery students. The reason why we have it for 8 years is because so after they graduate at high school, they have 4 years of either post-secondary or early career. So we studied the long-term impact in those 4 years, and then after 4 years, we can study more of the post-secondary school and post-early career impact as well. So that's why we have it at 8 years. We have built-in exit points. The reason why we have those is we recognize that an 8-year study, we will not be able to retain all the students. So the exit points just means that at 4 years, we're able to draw some conclusions, and then at 6 years, we're able to draw some conclusions. And then when we say long-term impacts, these are the key metrics that we're looking for. And they're in 2 different umbrellas. The first one we're looking for are the social and psychological long-term impacts. So their STEM attitude and interest, science self-efficacy, and the science identity. The second umbrella of key metrics fall into really their future pursuits, so the decisions, the decisions that they make. So their STEM academic pathways, their career attainment, and then their integration into the science community. And we collect data from these students in 3 ways. So at the very outset of the study, we administer a questionnaire to collect baseline information. The first method is to, we administer biannual closed-ended surveys. And then we do a in-depth interview for select candidates. And then on an ongoing basis, we monitor their LinkedIn profiles. And the three data collection strategies, the data collected from these three strategies is then analyzed in this way. So survey data is then converted into numerical data and interpreted then. Interview data is processed and validated with a coding scheme to identify key emerging patterns from the interviews. And then their LinkedIn profile data is then categorized based on career type and tracked along throughout the study. And the three types of data is then compressed to draw conclusions and findings. I guess, and then the next stage of this study is the implementation stage. So we've designed the study. The next step, if you can, I point to the diagram here. The blue one is where we're at now, and the green part is the implementation of the study, and it will likely be the fall 2021 cohort of Discovery students. And the impact of this type of study is that it gives educators and also the Discovery team information on the long-term impact of Discovery, and it gives evidence for further scale up and expansion of the program beyond, to more TDSB schools and also beyond. That concludes my presentation. I welcome any questions that you guys may have.
All right, thank you, Angelina, for your presentation.
Should I stop sharing or?
Keep your poster up there just in case judges has questions.
Okay.
And, I do want to remind Judge that this is the engineering education category, so do be mindful when you're submitting part. And now please raise your hand if you have any question for Angelina. All right, Professor Eleuterio, if you want to go.
Was that me?
Yes, sorry.
Okay, Eleuterio. Okay, very well. Thank you very much. Thank you for the presentation. This is an interesting study. I'm very curious about how this is going to go. Now, the students in this, they're going to be given a task or a project, and it's up to them to determine the method by which they accomplish this. Is that correct?
Correct. So they have a broad theme, and it's divided into physics, chemistry, and biology. And we have graduate students from the faculty that guide them through their methods. So they're not just out in the labs trying to figure it out. There are some guiding points, but the difference between this and traditional knowledge-based curriculum is they do make mistakes, and then they overcome those mistakes, and then it's the iterative and inquiry-focused part.
Okay, so I just want to be clear. So this is the underlying philosophy of the Discovery STEM initiative?
Yes.
Okay. Now, the actual question I wanted to ask, that was sort of kind of just some background, but the actual question I wanted to ask is, when you're analyzing the data, you had the 3 points there that you mentioned and is on your poster.
Yeah.
And I'm always curious about this because, you know, from my background, I'm always looking for quantitative measures. And you have only one of those bullets covers that, where you actually ask questions and you get numerical data on a 10-point scale. And this is often done. And I'm always curious about how does one normalize this? Because somebody's 10-point scale is going to be quite different than somebody else's 10-point scale.
Yeah. So the survey data is actually, so the survey questions, so the closed-ended survey questions are actually mostly going to be adapted from previous already validated surveys from the literature. So on STEM education and other longitudinal educational studies. So I think the key point is the validated survey because in our previous study, we didn't do a validated survey. And so the questions, like the results from the survey questions, like we can't really use because they were not consistent and standardized. So that is one thing we're working towards while we're developing these surveys, is to ensure that it's consistent and the 10-point scale actually translates to something and a result at the end.
Okay, thank you.
Thank you. Thank you for your question.
May I ask a question?